All right, so this video is on base 5 multiplication. And this is where maybe it starts to get a little bit really kind of weird, but we just need to think about what we're doing. So the first thing I'm going to work on is the multiplication table for this. But before I do that, I want to just say, for example, if I have 2 base 5 times 3 base 5. Okay. Remember what that means again, so I'm doing multiplication, is, right, it's repeated addition. So this is 3 base 5 plus 3 base 5. All right. So if you're still a little uncomfortable with the addition, you may need to go back and rewatch that. But basically what you've got is 3 plus 3. Now, in base 5, I'm thinking about this as 3 pennies and 3 pennies, right? It gives me a total of 6 pennies, but that's 1 nickel and 1 penny. So that's 1, 1 base 5. Don't say 11, that means base 10. 1, 1 base 5. Okay, so what we're going to do is we're going to sort of go through this and look at how to write down the multiplication table, or at least part of it. One of the nice things about this, you know, always 1 times things. It doesn't matter what the base is. 1 times 2 is 2, 1 times 3 is 3, etc. Right. Okay. 2 times 2, right? Let's just do one more of those. That's the same as 2 plus 2, right? Because that's repeated addition. So I have 2 pennies and 2 pennies makes 4 pennies. And I get that. Right? 2 times 3 is 1, 1 base 5. So all the stuff in here is base 5. I've got a little subscript 5 on the multiplication. All right. And then let me do one more. Let me do 3, say, times 4. Right? And what does that mean? Right? So that is 4 plus 4 plus 4. Right? Repeat 4 3 times. Okay. And again, by commutativity, that's also 3 4 times. So either is fine. So what you need to think about is this, is I've got 4 pennies and another 4 pennies and another 4 pennies. Right? So that's 12 pennies. 12 pennies, which is 2 nickels and 2 pennies. All right. So this 3 times 4 is 2, 2. And I don't say 22, that sort of connotates decimal stuff, so it's just 2, 2. These things. Okay, I'm going to leave the rest of that to you. It's really not very big, because remember a little bit about symmetry. We know 2 times 3 is 3 times 2, so you've got a whole bunch already filled in. But this is a good thing to know. All right. So let's look at some other things. So if we're doing higher order multiplication. So I'm going to say 1 digit multiplication. So let's do 4 times 2, 1, 3 base 5. Okay. So like we've done before, I want to do a coin or chip model. And we're going to do so this is, remember, again, what this means is 2, 1, 3 plus 2, 1, 3 plus 2, 1, 3 plus 2, 1, 3. So I've got 2, 1, 3, 2, 1, 3, and I've got 4 of those. All right. And then the last thing that we need to do is just to do some bundling of things to make everything work out right. So again, I'm going to grab 5 of these, and I'll make one there, and cross that out, and I'll do 5, say like that. Okay. Then I'm going to move to the 5s. There's 5, and whoop, that's gone. And then lastly with this is 5, and right there. So here's what I've got. I've got 1, I have 4, I have 1, and I have 2 left. Okay. Good. So let's see, this is where it starts to get a little bit tricky, I think. I think this is still pretty straightforward. And I'm going to do the column algorithm. So just like we've done before, 5, what was I going to do? I was going to do 4 times, 2, 3, 1. Okay, so we're going to do the same thing that we've done before. So 4 times 3. Okay, so in our heads, we know that's 12 in decimal, but what is it in 5? 12 means 2 nickels and 2 pennies. So I'm going to do my 2 pennies there and 2 nickels there. 4 times 1 is just 4, plus 2, right, is 6 in our head, which is 1 nickel and 1 penny. 4 times 2, right, is 8 in our head, but that means 1 nickel and 3 pennies. Add 1, 1 nickel and 4 pennies. Okay. By the way, even though these represent like 125s, 25s, 5s, and 10s, you can always think nickels and pennies in adjacent little groups like this. Okay, so we get that. All right, let me just show a couple of things here. This is, I think, the key thing of this, right? This represents this in a much more compact way, much quicker to do. Okay, this too are those 2 groupings or 2 bundlings of nickels, right? I've got 2 things of pennies that are 5s, and I make those 2. That's what that 2 is. That one is there, and that one basically is that last one, right? You could write it up high, but you can just put it there too. Right, so all of these little groupings are that. All right, let's do another one. I know this is kind of tricky. Let's do 3 times 1, 4, 1, 4, 4, say. Okay. Let's actually do it this way first. So 1, 1, 2, 3, 4, 1, 1, 2, 3, 4. And then rebundle. So there's 1. And that. 4, 5. And I'm left with 1, 2, 3, 4, so I don't need to do any more. 1, 2, 3, 4, 5. Fix that. So it looks like in this case, I've got 1. I'm going to cross this out. 0. That's why I like to cross this out. 1, 2, 3, 4. And I'm left with 2. Okay. All right, let's do the same thing over here. 3 times 4. Okay, that's, again, in our heads, there's 12. 2, 2. The other thing is if you finish off that multiplication table we went through earlier, you can just look at 3 times 4 and do 2, 2. 3 times 4 is 2, 2. Plus 2 is 4. 3 times 1 is 3. Plus 2 is 5, which means no pennies and 1 nickel. Okay. Again, these 2 rebundlings is that 2. These 2 rebundlings is that 2. That rebundling is that 1. Okay, and then the last thing that I want to do is a little bit more difficult one. Is I'm going to do 2-digit multiplication. Like this. Okay, and we'll try to do this. So 3 times 1 is 3. 3 times 4 is, again, 2, 2. So 2, 2, right? It's 12, but it's 2 nickels, 2 pennies. Okay, now I'm going to put as placeholder 0. 2 times 1 is 2. 2 times 4 is 8. 1, 3. 1 nickel and 3 pennies. And then add, that's 5, which is 0 nickels, sorry, 0 pennies, 1 nickel, 2. You get 2043. Okay. So, you really, I mean, just, it's really the same. It kind of, you got to just kind of think about stuff a little bit better, or different with this Base-5. Okay. So that will wrap up this video.